Going to share screen. So what we will start today is about machine learning. So last 3 weeks we discussed Python programming language and useful package for preparing of machine learning. So today we will start to discuss machine learning. So before we start to the topic, the first thing we need to know is about the 3 different types of machine learning. So generally speaking, we have 3 types: supervised learning, unsupervised learning, and reinforcement learning. So after this class, if you go to a job interview, people ask you the 3, then you should know that. Is it? So what is supervised learning? So supervised learning, that means the data already labeled. Be careful, okay, data already labeled. We will see today the first 2 simple algorithms. So data already labeled. Labeled means you classify data into different categories. Like the example later on we are going to discuss, like a flower. So flower based on some features, like a color or petal length or petal width, something like that. How do you identify if the flower is rose or some other flower? There's some kind of information like that. So that's called labeled data and supervised learning. So you can do classification and you can also do regression. The second is unsupervised learning. So unsupervised learning is data you have no idea. You just have the data, but you don't know what it is. So based on the data, then you need to do something. So we need to find the hidden pattern in the data. So normally we can find subgroups with clustering, and we can also do dimensionality reduction. So later on we will see that's quite a useful technology to remove noise. The third type is reinforcement learning. So reinforcement learning, like what? Like you play game. Okay, the to train game, that's based on the rewards. So it's a decision system and a reward system. So this is reinforcement learning. So you're going to develop a system that improves its performance based on reward. Based on reward. So like a game, is it like AlphaGo? So train AlphaGo, then it involves the concept of reinforcement learning. So it's not just supervised, also it's reinforcement learning. And then based on this definition, then how about ChatGPT? Is ChatGPT like supervised, unsupervised, or reinforcement learning? So ChatGPT, it's built on pre-trained model. When you build the pre-trained model, it uses unsupervised learning. And after that, it does fine-tune, then it uses supervised learning. So this is about the 3 types of machine learning. So today we will learn the 2 simplest: perceptron and adaptive linear neurons. And both of them are machine learning for classification. Be careful, okay, this is for classification. Okay, then here is the very, very basic idea about artificial neurons. So over here, we can see some early history of machine learning. And the first concept of the neuron, that we call it McCulloch-Pitts, so MCP neuron. So this is proposed by McCulloch and Pitts. So what the idea is, so you have some nerve cell and you have inputs. You have the inputs and then it does some reaction and will generate output signal. Okay, so this is trying to mimic the real world nerve system's reaction. So this is a very, very basic artificial neuron. And then a few years later, Frank Rosenblatt developed based on the MCP neuron. It developed the perceptron algorithm, perceptron rule. So what this perceptron rule algorithm is that perceptron, that artificial neuron, it can learn optimal weight coefficients. And the weight coefficients multiply with the input features and then make a decision whether the neuron will fire or not. So this is the concept. And then you can use this. So after you train the model, then you can use this model to predict if a sample belongs to a class or not. So this is the idea, okay? So here, about the idea about perception. And then here, we have this formal definition about artificial neuron. And here there are a lot of terms we need to know. The very first is the decision function. Decision function. And we have this concept of net input. Net input. And here, let's find those are key to the that input is linear. So for their perception, how it works is the net of the sample. For machine learning, people you can have a lot of samples. That's why. So if this net input is if it's greater or equal than certain threshold, say okay. No. Otherwise, you say it's some other form. Only when the x is greater than certain threshold, required to say okay to go. That's the concept here. Okay. Okay, and then for the threshold, here it says we can also bring it to the left of the equation so that we can set W0 as the negative value of that threshold. And we can make X0 as 1. X0 is not a sample, so you just force it to be 1. And then in this case, then what the decision function, it will change. It says if net input is greater or equal than 0, then it is some class. And also be careful. This term, learning, you need to know this term. Threshold bias. It's called bias. Okay, based on that, so that's just the math description, is it? And here we can clearly see what this means. So the decision function basically here it's a step function regarding that input. Is it? So it is either the class or it's not, if it's greater than 0. And here we can clearly see what this means, the decision function. So basically decision function will, so all of this are data. Data has some feature, x1, x2 are features. And you can clearly see those two data are in two different groups. One is red, one is blue. Is it? So with this, we can separate these two classes. And this is a linear separable class. So then the whole idea here is to find the weight. So how do we find the weight? So here we are going to discuss, we call it perceptron learning. So you can initialize the weight to some small random number. Then for each sample, you are going to calculate the output based on the weight. And you calculate this y hat. Y hat is the calculated. Okay, so how this learning number of because the purpose So you calculate the y hat, and then we update the weights. How we update the weights? So you are going to find the delta W. How do we calculate delta W? So the delta W is the real one and the calculated one, the difference, times your sample feature, times the eta. This is the real value, real output. This is calculated. The difference between times the feature, times the learning rate. That's eta. Eta is the learning rate. Then you can come up with this. Then you can update it. So you just say for that if you have a very good model, the weight will approach to the output. And be careful okay, about perceptron. It must be your model, your data. The sample must be linear separable. If it's not linear separable, it's not going to work. But there is a point, there is a disadvantage for perceptron. So that's why improvement on perceptron is adaptive linear neurons. And for adaptive linear neuron, it will converge of the learning. Adaptive, so add line. Add line. Add line, we also call it what? Batch gradient descent. And it was published by who? By Bernard Widlow and his doctoral student Ted Hawk, a few years after Frank Rosenblatt's perceptron algorithm. And it does some improvement. And the add line is very interesting. Okay, because what? Because So it's the form, the one of the and because of this, we can use frequency. Okay, frequency is that to make the ground to work more advanced when the other is actually the key is what is weight updating rather than a unit step function. What is that activation function? It's just that linear function of the weight times the. So we call it activation function. Okay. So let's see the difference between these two. Okay, for perceptor, you use a step function, and then you find the error, you feed back to update the weights. But here, you use that linear activation function, and you do the weight updates. So what is that? Okay, what is that? So here, another very important concept. Here is KW. What is KW? KW is called. We call it control. That's so over here. Over here, we use what? We use sum of square of arrows. In this case, as what? As the cost function. Cost function. Okay. And because, think about, so you all learn that. Very basic. Very basic. So this function will kind of You want to find the minimum. Okay. That's how we come up with gradient descent. Now we come up with this gradient descent concept. And even though you have the derivative, but that's not applicable in the real world machine learning. The machine learning approach to the solution using gradient descent to minimize the cost of function. Because it's quadratic. So this is the cost of function. This is the weight. So the relationship between the cost and the weight is quadratic. It's a bear. Because it's a bear, it will have minimum value, the lowest point. So our goal is to find this global minimum cost point. How do we find? We are not going to do mass derivative. Decent is what? You set up the initial weight. Initial weight, you don't really just set up random value. And then, because what you have, you know the slope. Slope is gradient. It's called gradient. Then calculate the delta W. So once you calculate the delta W, then you can move to the next move. So you can review your approach. That's why we call it gradient. Does this make sense? All of this idea? Okay, so here to give us minimize cost with gradient descent, how we are going to do it is that we use gradient descent, we can update the weights, take a step at a time. We can find the delta W. How do we find the delta W? So delta W is the learning rate times what? Times the gradient. What is this gradient? Learning rate. Gradient. How do you find this gradient? So you the lower output and the calculated actually times the future. So for each example, you can do this. Then you can calculate the delta W. Once you calculate the delta W, you can update it. Once you update, you can keep it. That's why we call it gradient. And you can find the approaches may not be exactly, but around that area. The local minimum point. Okay, so that's the whole idea about gradient descent. So how we find the delta W? Here it says, okay, learning rate times the gradient. And in this quadratic expression cases, the gradient can be calculated like this. And then you just update the weight. So that's the whole idea. And here it gives us the more math background behind this. Okay, so we are going next to take a look at our because that's what we care the most about the coding. So previously we learned pandas, numpy, and that those are not machine learning. Okay, and today we start with machine learning. So in machine learning, for classical machine learning, Python has a very nice package called sklearn. sklearn. So use this a lot. sklearn. Okay. Here. And you can see machine learning is also those are very classic data about others data. Okay, this is a very classic machine learning data set. So what it looks like, so this is the data. It has 150 data points. Not a very small one. So if you like pedal width, pedal length, something like that. So this is the first one. Here, it gives you the flowers. So what here we have is 4 features. 4 features. Okay, like a pedal length, pedal width, something, 4 features. And what is this one? The last one. So we have x1, x2, x3, x4. Those are 4 features. And the last one is a string, like iris, so what is it? This is flower. Class. So it has a feature. It has a class. So that's why we see this is so the data already labeled. Data label. Okay, so this is why it's supervised learning. Okay, so all this 150 samples, they are called samples. Okay, and then you train the sample to find the best weight So corresponding to this, you have W1, W2, W3, W4. And these weights are unknown. Unknown. That's what the machine learning is going to train. And use what to train? Use gradient descent to train. The gradient descent train based on what? Based on the cost function. Is it? So what is the cost function? Cost function is y value minus yi hat value. That's a difference. Is it? And you want to sum them. And you want to minimize. Because this y hat is based on what? It's based on the calculation. Is it? It's sigma wix. This is the real one. From that 150. You see the idea here? So then you find the optimal number, the weight. Okay. And how do we find the goal? This is your goal. Your goal is to minimize the cost. The function. That's your goal. Is it? You necessarily know that this function is what? It's a quadratic. Of W out. Because it's quadratic, then we know you try to minimize, you can take the derivative. What is derivative here? It's free. The gradient is the slope. That's how we come up with this bear. And then, so here is the cost function. KW. And this is W. And you want to find, go to this point. How do you go? You initialize. So this is initial W. And then you know the gradient. This gradient, you know. And because you know the gradient, then you can find this delta W. Because of the delta W, then you can update. You keep updating the W until you are in this area. So that's the whole point. So see how nice this is. This, yeah. So you find this point, and once you find this value will be the minimum one. Then each time, if we have a new sample, with a new sample, For example, you have x1 u, x2 u, x3 u, x4 u. And then on this then you can use that wi to find the y hat. And so the weight is the ultimate. So this is the ultimate. And this ultimate weight may be close to y. So you see, even though you may not know why you do what you did, based on the because you don't know what you said. That makes sense now? Okay, then let's come to take a look. This in Python, how do we do this? I just mentioned, okay. So the percent and the alpha according to their code. Alpha is classic in Python. Okay, and for that iris data, the SPLab already has that data already in the link. The directory can load this data. And here we are not going to use all the things. We are just going to use 0, 1, 2, 3. These are the two we're going to use. And we're going to take pricing for all rows. That's pricing for all rows. We're not going to consider all 150 samples. And what is y? Y is what the flower class is. And so the GL. So here we have 3 classes. Okay. Right over here. So that's why this is the label data. For label data, and here we do classification. And with this classification, we supervise. Learning. Okay. And here let's do some data stage. The first 10 sample data, check and detected Y. How many unique Y value we have? So here it shows us the data. The first 10 data. We have 150. Is it? Okay, and then to the next. When we do machine learning, learn the first step. Step number one is to split the samples into training, test, and testing data set. And based on the feature and the target, and you have to define the region and give them to 70% data for training, 30% data for testing. Okay. And you can also specify the other two parameters. So the stratify is the key as original position, proportion, and this is just to reproduce. The training and the testing. So did you see? Then you have X and X test. You have different sets. Okay, this is set 150. So here you have X1, X2, X3, X4. Again, then the second X1 is still 150 of this. And then after that, you have 70% of training and the 30%. That's how this two parts come up. Okay, and then what next? You just count the total number of different classes. Within each class, how many data sets you have? How many samples you have? And the same thing for training and testing. In ML-4, we need to do data pre-processing. Data standardization. scaling. Okay, why do we need to do this? Just think about it. I'm thinking about the where fit. And the X may be number of bedrooms. And this barefoot can be large. Can be like 200. And this just a single digit. So the scale of this stat are not the same. It's not the theoretically speaking. Making users is impossible. So in order to make the data the same scale, we do data scaling and standardization. So that is you're going to have your data around the mean value. Okay, around the mean value with standard deviation. Standard deviation. And then normally over here, the median value is 0 and 1. Okay. And for SQL, it's quite simple. You just import this in the code. Then you feed your key. Then you transform it. Okay. So it's pretty straightforward. You transform your data, you scale your data before you do the training. Then here, after the perception model. So you first need to create perception model. So this is number of iterations. And this is the learning rate. Learning rate. So you create this model. Then you use those skills that train. To train. We just call what? Call the method to train. Okay, to train. After you train, that's what the next comes. Here you call predict. So predict is what? We testing that. So that's standardization and scaling. And then next step. Train. Data is training sample. Okay, with training sample. Normally you call the data set. Lesson. After that, the next step. Next step is data with the predict method. Predict, you have y predict. Y predict also have y test. So the predicted may not be the same as test. So you want to know how accurate the model is. So from ST method, you import accuracy score. Then you can find your model's accuracy. And you can also use the score method. So testing data and then find model accuracy. Okay, and after this, if it's pretty good like this one, accuracy can reach 93%. That's pretty high. So whenever you have a new data sample, you feed it, you will get a classification. And it's 93% accurate, not 100%. Okay, this is still pretty good. Okay. And the last part of this example is about plotting. And I think you need to learn plotting on your own. That after that, you can understand this plotting part. And let's stop here today. And